solution is prepared by dissolving 9.0. This one is a mess of sodium chloride in deionized water in 500 ml volume in volumetric flux. So we need to calculate the molarity of the solution. From here, we have two formulas, molarity and number of mole. For the molarity, the formula is mole of solute over the volume of solution. For the number of mole, we have mass over molar mass. So from this question, we already know the mass of sodium chloride, 9.0 gram. We can determine the mass of sodium chloride, which is 23 plus 35.5, and we got 58.5 gram mole. After we got the gram mole and mass, the molar mass and mass, we can determine the number of mole before we substitute. Before we use this formula, we need to find the mole of solute first. So we have this formula to find the number of mole. Mass over molar mass, 9.0 gram over 58.5 gram mole, and we get 0.1538 mole. After we got the number of mole, we can substitute to this formula, 0.1538 mole over the volume. The volume that we get is millimeter unit, and we need to change to liter unit, which is 500 multiplied with 10 minus 3, and we get 0.5 liter. And we can substitute to get the molarity, 0.1538 mole over 0.5 liter, and we get 0.3076 molarity. Nitric oxide NO react with oxygen to produce nitrogen dioxide NO2 minus. So we have this balanced equation. In the experiment, 0.53 mole of nitric oxide is mixed with 0.3 mole of oxygen. So we need to calculate the volume of nitrogen oxide produced at STP. Okay, we will rewrite again the balanced equation. 2 nitric oxide plus oxygen produce 2 nitrogen dioxide. Nitric oxide we have 0.53 mole, and oxygen we have 0.3 mole. This one is the mole given. From the balanced equation, 2 mole of nitric oxide equivalent with 1 mole of oxygen. So we need to find the mole needed. We use the X equation, mole of nitric oxide equivalent with 0.3 mole of oxygen. So we want to find the mole needed of nitric oxide equal to 0.3 mole of oxygen over 1 mole oxygen multiply with 2 mole nitric oxide, and then we got 0.6 mole of nitric oxide. This is a new, or we call it as the mole needed. So we already know meeting reactant happen when mole needed is bigger or more than mole given. For the excess reactant, mole needed is less than mole given. So from this, since mole of nitric oxide needed 0.6 is more than mole of nitric given, we know 0.53 mole. So nitric oxide is a limiting reactant and oxygen is an excess reactant. Next, from the balanced equation, we need to find the mole of nitrogen dioxide. So 2 mole nitric oxide equivalent with 2 mole nitrogen dioxide. 0.53 mole nitric oxide equivalent with X mole nitrogen dioxide. Why? Because we need to find the mole for the nitrogen dioxide. So 0.53 mole nitric oxide over 2 mole nitric oxide multiplied with 2 mole nitrogen dioxide, and we got 0.53 mole of nitrogen dioxide. Okay, the question asks for volume. We need to calculate the volume of nitrogen dioxide in STP. Okay, STP we know is 22.4. So we use this formula to find the volume that produced at STP, 22.4. Number of mole equal to volume over molar volume. So we substitute the number in this formula, 0.53 mole equal with volume of nitrogen dioxide over 22.4, and we got volume of nitrogen dioxide 0.53 mole multiplied with 22.4 liter mole negative 1, and we got the volume of nitrogen dioxide is 11.87 liter. For the next question, number C, a 25.0 mm is a volume solution containing oxalate C2O4 to minus ion was titrated with KMnO4. Solution in acidic medium, C2O4 to minus ion will oxidize to CO2 and MnO4 minus ion will reduce to Mn2 plus ion if 30.50 mm volume of 1.25 PSPM KMKph solution is required for the titration. So the question is, we need to write the balance equation for the titration. To write the balance equation, we can use stoichiometry. First, we write C2O42 minus plus MnO4 minus that can produce CO2 plus Mn2 plus. Okay, we can separate into two from the oxidation and reduction. We know that C2O42 minus is an oxidation and MnO4 minus is a reduction. This is the first step. The second step, we need to balance the equation. C2O42 minus produce 2CO2. And then for the reduction, MnO4 minus produce Mn2 plus 4H2O. We need to add the H2O in the part that doesn't have oxygen. For the step number 3, is the same. C2O42 minus produce 2CO2, but for the reduction, MnO4 minus plus 8H plus that produce Mn2 plus 4H2O. We add H plus in the part that doesn't have H2O. For the fourth step, C2O42 minus produce 2CO2 plus 2 electron. We have 2 electrons in the oxidation and we can cancel to each other. For the reduction, the electron is MnO4 minus plus 8H plus 5 electron that can produce Mn2 plus 4H2O. We add the electron in the part that a bigger oxidation number. And then the next step, we need to make the electron be the same number. Okay, for the oxidation, we have 2 electrons, and for the reduction, we have 5 electrons. So for the oxidation, we can multiply with 5, and the reduction, we can multiply with 2. So the next step, we get, after we multiply with 5 for the oxidation, we got 5C2O42 minus that produce 10CO2 plus 10 electron. For the reduction, after we multiply with 2 MnO4 minus plus 16H plus 10 electron produce 2 Mn2 plus 8H2O. And then we need to remove the same electron. And we got 5C2O42 minus produce 10CO2, and for the reduction we got 2 MnO4 minus plus 16H plus produce 2 Mn2 plus 8H2O. And we can get the balance equation for the titration. 5C2O42 minus plus 2 MnO4 minus plus 16H plus produce 10CO2 plus 2 Mn2 plus 8H2O that we combine together. The oxidation and reduction we combine together to get the balance equation for the titration. Next, for the next question is, we need to calculate the concentration of the solution containing C2O42 minus ion. We know concentration is the molarity, so we can use this formula to find the concentration. So, molarity C2O42 minus multiply with volume for C2O42 minus over molarity for MnO4 minus multiply with volume MnO4 minus equal with mole of C2O42 minus over mole of MnO4 minus. So we substitute the number in this formula. So M molarity for C2O42 minus equal with 25 mm over 1.25 M multiplied with 30.50 mm equal to mole of the C2O42 minus, which is 5, and MnO4 minus, which is 2. So got 25 MC2O42 minus over 38.125 equal to 5 over 2. And then we simplify with the basic mathematics. 2 multiply with 25 molarity of C2O42 minus equal to 5 multiplied with 38.125. And then we got the molarity for C2O42 minus is 190.63 over 15, and we got the molarity for the C2O42 minus is 3.81 molarity. For question D, Freon 12 CCl2F2 is used in various manufacturing industries. It is produced from the reaction of carbon tetrachloride CCl4 with antimony trifluoride. So we have the balance equation 3CCl4 plus 2SbF3 that produce 3CCl2F2 plus 2SbCl3. So the question is, if 130 CCl4 is mixed with 19.5 gram of SbF3, we need to calculate the expected mass of CCl2F2. Okay, first we need to find the mole to know what the mole that the question given. So, to find the mole, mass over molar mass, 130 gram over the molar mass 12 plus 4 multiplied with 35.5 gram mole, and we got 0.8442 mole, and here is the mole given for the CCl4. Next, mole number of SBF3 is 55 gram over 121.8 plus 19 multiplied with 3, and we got 0.5313 mole. This is the mole given for the SBF3. Next, we need to find the mole needed. From the balance equation, 3 mole CCl4 equivalent with 2 mole SBF3, and we want to find the mole needed for the SBF3. So, 0.8442 mole CCl4 over with 3 mole CCl4 multiplied with 2 mole SBF3. And then we calculate, and we got the mole needed, which is 0.5628 mole for the SBF3. So, we already know that mole needed for the SBF3 is bigger than mole given, 0.5313 mole. So, when the mole needed is bigger than mole given, we know the SBF3 is a limiting reactant and CCl4 is excess reactant. Next, we want to know the mole for the CCl2F2. So, from the balance equation, the limiting reactant need to equal with CCl2F2. So, 2 mole of SBF3 equal with 3 mole CCl2F2. We substitute with the mole given for the SBF3, 0.5313 mole SBF3 equal with X mole CCl2F2. So we need to find the mole for the CCl2F2, 0.5313 mole SBF3 over with 2 mole SBF3 multiplied with 3 mole CCl2F2. So we got the 0.79695 mole CCl2. So we got the mole for the CCl2. After we know the mole, we need to find the expected mass, which is we need to find the mass for the CCl2F2. We substitute with this formula, number of mole equal mass over molar mass. We substitute the number of mole, 0.79695 equal to mass CCl2F2 over molar mass for CCl2F2, 12 plus 2 multiplied with 35.5 plus 2 multiplied with 19 gram mole. So, 0.79695 mole multiplied with 121 gram mole, and we got the mass of CCl2F2 is 96.43 gram. Next question, we need to find the percentage yield if 19 gram of CCl2F2 was obtained. So we have the formula for the percentage yield equal actual yield over theoretical yield multiplied with 100%. So we substitute the formula, percentage yield equal with 19 gram over theoretical yield, which is 96.43 gram multiplied with 100%, and we got 93.31%. Okay, for the next question, we need to find the amount of excess reactant after the reaction is completed. So, we need to find the excess reactant. From this question, the excess reactant is CCl4. So, from the balance equation, we need to find the mole needed for the CCl4. So, 3 mole CCl4 equivalent with 2 mole SBF3, and we need to find the mole needed. So, 0.5313 mole SBF3 over the 2 mole SBF3 multiplied with 3 mole CCl4. So, we got for the mole needed CCl4 is 0.79695 mole. So, we can find the excess mole and the excess mass. So, the excess mole we can get from the mole given minus with mole needed. So, mole given for CCl4 is 0.8442 and mole needed for CCl4 is 0.79695. So, we got 0.0473 mole for the excess mole. And then, we can find the excess mass of CCl4. So, mass of CCl4 is number of mole multiplied with molar mass for CCl4. Number of mole for CCl4 is 0.79695 mole multiplied with molar mass 12 plus 4 multiplied 35.5 gram mole. So, we got 122.73 gram. And then we can find the excess mass of CCl4 is the mass given minus with mass of CCl4 needed. So, 130 gram minus with 122.73 gram, and we got 7.27 gram.